All right, the last technique that we're going to look at for solving quadratic is the quadratic formula. I'm going to preface this right at the beginning by saying I will never ask you to solve a quadratic by using the quadratic formula. I will ask you to solve a quadratic by factoring. I will ask you to solve a quadratic by completing the square. If I ask you to solve a quadratic and I don't specify the technique, you may feel free to use the quadratic formula if you wish. So Theorem 8 just says, say we have this quadratic equation in this general form, ax squared plus bx plus c equals 0, like that's important here. Then the solution to the quadratic is given by the values that this formula spits out. So, you know, this formula is really a result of completing the square to solve this generic quadratic equation. So we're going to do that to begin with here. So I know that to solve a quadratic, I got to get the constant by itself on the other side, so I'm going to subtract c from both sides. And we also know that we need to complete the square on 1x squared, right? We need to make sure that coefficient on x squared is positive 1. So I'm going to divide both sides by a, which is the same as dividing all terms by a. So now we have x squared plus b over a times x. I want to kind of really see that as the coefficient on x rather than write it as bx over a. And then I'm leaving space for the magic there, and I've got negative c over a on the other side. Now is when we're ready to complete the square, right? We're going to be terribly clever about choosing a value to add to both sides. And we always get it by looking at this coefficient on x, cutting it in half, and squaring it. So this is a fraction b over a, and there's two ways that you could think of cutting a fraction in half. One is by cutting, is by halving the numerator, right? Cutting the numerator in half. And the other is by just doubling the denominator. So half of b over a is b over 2a. So we're going to take that and square it and add to both sides. All right, the reason we did that, the reason it was so clever to add the square of b over 2a to both sides is because the left side is a perfect square. This is what a perfect square looks like. I grab the x, I grab the positive b over 2a, and this is equal to, let's see, negative c over a plus, and then we're going to square this fraction, so we could distribute an exponent over the top and the bottom. So I got b squared over, and 2a all squared, 2a times 2a is 4a squared. I'm going to simplify that sum. I'm going to just add those fractions on the right side. Let's get a common denominator. So we multiply the top and the bottom of this first guy by 4a. So that's negative 4ac plus b squared over 4a squared. So down here I'm just going to rewrite that. I'm going to start it with a positive. So b squared minus 4ac all over 4a squared. All right, now I've got this perfect square on the left. That's where my x lives. And then I've got this fraction on the right. Let's take the square root on both sides. On the left now we have x plus b over 2a equals, on the right side, plus or minus. I'm going to split up this fraction over, or split up the radical over division here. So square root of b squared minus 4ac over the square root of 4a squared. The square root of 4a squared, well, that is 2a. And now we can solve by subtracting b over 2a from both sides. So now we have minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. And we have a common denominator, so let's go ahead and write it as a single fraction. So 2a on the bottom, up top we have negative b plus or minus the square root of b squared minus 4ac. And that is what the quadratic formula is. Alright, so now we're just going to solve some equations by using the quadratic formula. Usually, most of the time I wouldn't choose the quadratic formula because, well, first of all, completing the square is just really enjoyable. So I usually like to complete the square. There are some cases where using the quadratic formula is just more convenient. So we're going to start here. This one is already set equal to 0. That's the first thing you got to make sure you're looking at is quadratic equations set equal to 0, and then identify the values of a, b, and c. So here a is equal to 1, b is equal to negative 6, c is equal to positive 3. And then I start by writing out the quadratic formula. So negative b is a positive 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 3 all over 2a, 2 times 1. And then we simplify. So simplify, kind of focus on the radical here. So we get 36 minus 12. Well, that's 24 all over 2. And then we want to simplify. We really do want to simplify these. So let's see, if we factor 24, we have a pair of 2's we could take out, and then we're left with the 6 still inside. And we can reduce this. Up top, there's a common factor of 2. And then we cancel. So we get 3 plus or minus root 6. On an equation like this, I would solve probably just by completing the square. I know that I would not solve by factoring because, look, the result, the answer that we got involved a radical, right? The best I could do is leave the radical in, or if you like, you could approximate. But getting an answer that looks like this means that this was not ever going to factor to begin with. Now, in example 712, I guess this is probably an example of an equation I might solve by using the quadratic formula, just because the numbers are, inconvenient. We got these decimals, and it's just not quite as satisfying to complete the square on this. So I'm going to start. I want to make sure it's written in that general form. So I'm going to subtract 0.72x from both sides. We get 0.37x squared minus 0.72x minus 0.15 equals 0. Now a is equal to 0.37, b is equal to a negative 0.72, c is equal to negative 0.15. I'm going to write out the quadratic formula. So negative b is a positive 0.72, And then we have b squared minus 4 times a times c all over 2a is 2 times 0.37. Okay. At this point, I'm going to turn to the calculator and simplify the stuff in the radical. So negative 0.72 squared minus 4 times 0.37 times negative 0.15. 0.7404. And then 2 times 0.37 is 0.74. So now we have, we've got sort of a simplified-ish expression here. We've got these decimals. I think we're ready to just kind of be able to get our approximate answers. I'm going to throw these in the calculator. I'm going to have to do some rounding. Oops. Parentheses, 0.72 plus the radical 7404 divided by 0.74. And that's 2.136. And I'm going to just bring up my entry, change that to a minus. Negative 0.1898. All right. Let's solve an applied problem. Here they tell us that the length of a poster, 15 centimeters longer than its width. And then they tell us that the area of the poster is 3,850 square centimeters. What are its dimensions? So we want to know the length and the width. So, you know, here's our poster, right? It's got some width here and a length. We know that the area is 3,850 square centimeters. And then they say that the length is 15 centimeters longer than its width. So that's W plus 15. And here we're just going to use the fact that we know how to find the area of a rectangle, right? The area of a rectangle is length times width. So that means that if I multiply the width times width plus 15, it's going to give me this area, 3,850 square centimeters. I'm going to distribute the W, so we get W squared plus 15W equals 3,850. And I guess because this is in the section on quadratic formula, we'll go ahead and solve by using the quadratic formula. But if I were solving this, I would just as soon actually complete the square on both sides. We'd be ready to take that step. All right, so I'm going to subtract 3,850 from both sides. We get W squared plus 15W minus 3,850 equals 0. This is now in that general form where we're ready to use the quadratic formula. A is equal to 1, B is equal to 15, C is equal to negative 3,850. Writing out the quadratic formula. So negative 15 plus or minus the square root of, 15 squared minus 4 times 1 times negative 3,850 all over 2 times 1. Now, I'm going to use the calculator to figure out what we've got in that radical. So 15 squared minus 4 times 1 times a negative 3850. That's 15,625. The square root of 15,625 is 125. This is a perfect square. So before we finish solving, we'll just note that because it's a perfect square, that's an indication that this quadratic up here, that this was factorable. You know, I might still use another technique to solve anyway, because 3850, there's just so many things you could multiply to get 3850, and I feel like I'd have to look for a while to find the things that would work to factor that expression. So anyway, we get, let's finish this off, negative 15 plus 125 over 2 is 55. And the other solution, negative 15 minus 125 over 2, that's negative 70. So again, we get two possible candidates for the value of the width. Now the width is not going to be negative, so we can eliminate this one, right? It's just not feasible. So that means the width is 55 centimeters. So, and the length is 15 centimeters more. So the length is 70 centimeters. The width is 55 centimeters. And that's what we were asked to find. Before we close out this section, I just want to take a few minutes to discuss, if we take a look at the quadratic formula. You know, when we plug stuff in, right, and we get it set up, the very next thing we always do, or that you've seen me always do at least, is that I say, okay, let's take a look at this. You know, what do we get in that radical, right? Because it helps me simplify, or maybe just evaluate, calculate it. That expression, b squared minus 4ac, is called the discriminant. And the value that it takes on has ramifications or implications for the types of solutions that we get for a quadratic. So if it is positive, that means that our quadratic will have two real solutions, like real number solutions. If it's 0, that means you get one solution, and it's real. And if it's negative, that means that there is no real solution. Emphasis on real. Most of the time when we're solving these, we're looking for a real solution. So, you know, when you're solving them and you find that the discriminant is negative, or you can also notice that if you're solving by completing the square, and when you get to that step where you're ready to take the square root on both sides, you find that you have to take the square root of a negative on the right side. That's the same situation here. At that point, usually we just say, oh, there's no real solution. There's no solution. However, if we are considering complex numbers, if we're considering imaginary numbers, there would still be two solutions. All right. So that finishes up this chapter. We now have 3 techniques for solving a quadratic. Remember that I'm never going to ask you to use the quadratic formula. I will ask you to factor. I will ask you to complete the square. So please do not use the quadratic formula as a means to avoid learning the other two techniques, because that will work out less than ideal for you. Okay, I think we're done.